Welcome to WPS Digital Learning Library and Computer Science presentation. My name is Rashmi Pimprakar. I am Pre-K-12 District Coordinator for Digital Learning, Library and Computer Science. Today we'll discuss a bit about the national as well as state standards that are used in our courses, points of entries or the course selections that we have available at each school. Uh, we'll also talk about digital learning and what it looks like in WPS, the library media program and the computer science program as it exists in WPS, and a little bit about the computer science and STEM week programming that we do at our schools. And finally, we'll also talk about resources which will help you explore our programs a little bit more. WPS believes in personalized learning, and we believe that it makes it possible to address the diverse needs of all our students while they're pursuing their individual paths towards becoming enthusiastic, empowered participants in a global society. We know that digital learning amplifies the impact of great teaching, and to that end, we use the SAMR model, which essentially talks about substitution, augmentation, modification, and redefinition, with the goal that students will eventually use technology to solve problems or to create new tasks as well as sort of solutions that are not necessarily existent right now, but they are being very creative in solving problems. There is a quick link here for what SAMR is, and it would be a really great resource for you to quickly take a look at that. SAMR model promotes active use of computing, which in turn helps us address the digital use divide that continues to exist between learners who are using technology in active, creative ways to support their learning, as opposed to those who predominantly use technology for passive content consumption. In WPS, we have a intentional focus of making usage of technology more creative and hands-on so that students are solving problems and are creatively interacting with the technology to solve problems. The different points of entries or course selections that are available at our pre-K-12 schools are the Digital Learning Library Media course, which is taught to all students at the elementary school. We also have library media courses at middle school and high school. We have transdisciplinary project-based learning, which allows for a lot of meaningful, purposeful classroom collaboration. There is a Fab Lab design thinking course that's offered at high school. There are also a few computer science courses that are offered at the high school. The first one is the Introduction to Computer Science 1 with Snap programming. Second is the Introduction to Computer Science 2 with Python programming. And the third one is essentially the AP Computer Science A with Java programming. We also try to integrate computational thinking across curriculum in different classrooms across pre-K-12 so that students have a more holistic approach towards computing as well as technology. There are also meaningful ways in which WPS tries to integrate and excite families in integrating STEAM and computing into their curriculum. And that is, we do so by offering multiple vacation family STEAM coding camps. We also celebrate STEM Week, CSED Week, and Media Literacy Weeks, engaging families and companies in the community to sort of engage with our students. The standards that we follow are the library standards, which are national library standards. We also look at Massachusetts Digital Literacy and Computer Science standards as we are developing our curriculum, in addition to ISTE, which is International Society of Technology Education, which are the leading national EdTech standards. We also try to have a very meaningful and purposeful mix of digital literacy and computer science so that students are sort of utilizing these skill sets and frameworks to seamlessly go between these tools and standards as they are documented in these different frameworks. We believe in integration and transdisciplinary approach across curriculum. So, having this Venn diagram of math, science, and English language arts as technology supports these core content areas is one of the most meaningful ways in which we approach technology integration. And we view students' digital learning experience more holistically with this digital ISTE standards for students, where we see them as empowered student learners, digital citizens, knowledge constructors, innovative designers, computational thinkers, creative communicators, and global collaborators. So, those are sort of the guidelines within which we design our curriculum so that students have multiple opportunities to get empowered in these standards. Here are a few educational apps that are available in our schools. We follow guidelines for student data privacy very proactively so that students have access to applications and their data is protected within the student data privacy contracts. So this is an example of our we have student technology app services guidelines, and here is a link to our student resources database where all of our applications are going through a process of student data privacy contract and allows us to advocate for right applications, right digital learning services, and student data privacy. We also support multitude of systems which support learning in classrooms, and here are a few. As I mentioned, we partner with the Massachusetts Student Privacy Alliance. We are a member of the Massachusetts Student Privacy Alliance, and we have, as I mentioned, we have app services guidelines. We have a link to the student resources database, as I showed you, and we have a link to how to request student digital resource request so that we can put it through the SDPA contract process. Here is the link to our website where you can always go and find these resources. In addition to that, our digital learning website hosts multitude of resources which are targeted towards faculty, students, and families. We also host a range of STEM Week, CSED Week, and library resources. For instance, this is our STEM Week website where, as you can see in our curriculum and learning opportunities, there are multiple access points to look into the EI engineering curriculum or PLTW curriculum. We also have STEM Week challenges that we've designed every week, every year, which are posted here, which teachers can have access to, and they go from pre-K 12. So we have secondary K 12 challenges that you can access. In addition to that, we also have a predominantly interdisciplinary learning focus where you can also look into the I2 challenges that are being offered. Same goes with our computer science week website where you can see that there are wonderful videos and resources that are available on the pages in addition to the curriculum, where you can see that the curriculum is divided in elementary, middle, and high school curriculums. So if you look at the elementary curriculum, you can see there are many different applications that you can look into, and they are wonderful challenges the students can undertake as they are interacting with different challenges and or specific curriculum events such as spin draw or I make algorithm, and they can actually click on these and go to those activities and do those. We again try to have a more integrated approach. As you can see, we have an English biography using Scratch example, or we have sort of responsible consumption and production, which is another wonderful activity that you can engage with, which are again very transdisciplinary in nature. We follow this national spectrum for physical computing, which sort of advocates for educational robotics, microcontrollers, and microcomputers. And you can see that at grade K, you will see usage of BBOT being extended from K to 2. and EV3s are being used in grade 11 and 12. So we have a spectrum, and we intend to have kits for all of these, at least district kits that schools can borrow for each of these activities. And these are some of the kits that we are trying to cultivate so that schools will have access to each one of them. Currently, we have a set of BBOTs in each of the elementary schools, and a set of 10 microbits available for middle and high school so that they can integrate it in the classrooms. Again, the focus is always interdisciplinary approach to integrating computational thinking or STEM into curriculum. So you can see that there are examples of creating a ball bearing, which speaks a lot about design, prototyping, going through that iterative process, and also utilizing mathematical concepts as well as concepts of physics and friction to create an object like that. Or a conic section where you're discussing circle, ellipse, parabola, hyperbola, so on and so forth. You can also see that there are multiple projects at different design levels where you can see students developing bridges or designing a makey water cycle, or using Scratch where they are utilizing conditional operators and designing an interactive water cycle or an interactive cell model. There are multiple interdisciplinary projects, as you can see, that students are engaged in, or they are which are something that they're using in a real context. So if they're designing a step counter prototype, we're also trying to cultivate these resources and post them on our computer science curriculum website or our STEM Week website, so that people will have access. Teachers and students and families will have access to those. Um, a lot of interdisciplinary reading or transdisciplinary literature is being accessed in our libraries. Again, as you can see, a circuit playground is used for disaster detector exercise. And then we talk about articles through Newsella, which sort of address and target this kind of learning. Um, we have These are examples of students interdisciplinary learning. This particular one are from scratch, so you can see some projects range from global warming to inspirational women in Black History Month, depending on the topic of discussion in the classroom. And these projects are examples, but they can be modified, adapted to what the learning is about in the classroom. Our library program and the Fab Lab program at both middle and high school as well as elementary school instruct students to with an intention of nurturing students' intellectual and social growth. It helps translate curriculum frameworks into authentic learning activities. It also helps in identifying, acquiring, and organizing resources to support all areas of curriculum, particularly improving sort of teaching of effective literacies, information, and research skills, so that students are enabled to acquire, judge, and use information, and of course create new knowledge. We are always intentional and purposeful in our effort in providing authentic, real world transdisciplinary project based learning, so that students can engage with the projects or the problems that they are seeing in a day to day life or in the real world, and can sort of try and find solutions to those. We also have a huge database collection accessible to our students, in addition to research guides. And both WMS and WHS maintains a very impressive print and ebook collection. So does our elementary school. Why computer science? WPS believes in computer science being one of the very stronger literacies that students need to sort of be change agents in today's world. We really do believe that computer science is in everything, in implementation of everything, and hence an effective tool that enables that kind of transition. Here is a quick video which believes in our philosophy as well.
I think 19th century was about the Industrial Revolution, about electricity, about disrupting the agricultural society and making it more advanced. The 20th century was about physics and engineering to do more things easier in our everyday life, from refrigerators to washing machines. How convenient. And the 21st century is definitely the digital age. It's the internet.
Even if you want to become a race car driver or play baseball, or build a house, all of these things have been turned upside down by software.
The lettuce bot is a robot that can sense its environment. Every single hour, this lettuce bot is seeing 1.5 million plants, and it's taking individual action on those plants. We enable lettuce growers to have higher yields in their field by helping make it cheaper, by helping produce food in a more sustainable way. And that wasn't previously possible without computer science and technology.
This is a really great resource that you can access, and there are multiple, it's a video series which advocates for how computer science or computing, knowledge of computing is effective as a tool in solving problems in different areas. Here is another example of John Hopkins Computer Science Resource Center that has created this COVID map, and this was a snapshot from 2 days back, which is a great tool for data visualization of real-time data visualization. Again, utilizing computer programming as a skill set or a tool. So with that in mind, there are specific integration efforts across pre-K 8 in our elementary, early childhood, elementary, and middle school programs. We try to integrate computer science into our classroom core curriculum. There is an introduction to Scratch course, elective course that's offered at middle school. And then there are also CS courses that are offered at high school. There are three particular ones. The first one is the introduction to CS with Snap programming. This course is intended for students who want to sort of broaden and deepen their knowledge about computers. And topics include designs, using Snap programming language, getting acquainted to it, and certain aspects of computer science programming, which are more interactive. The Introduction to CS with Python course is intended for students who want a more in-depth introduction to computer programming and sort of other aspects of computer science. And this course prepares students who want to go into advanced placement computer science APCS course, as well as those who do not intend to maybe take APCS later on, but also want to know a little bit more about algorithms, procedures, functions, variables, data structures, possibly recursive programming, so that they can use it in other contexts and solve problems. We advocate for debugging, troubleshooting skills, so that students are building that framework as they are engaging with CS, not just in the CS classrooms, but outside and integrating into other classes. Finally, we have an AP Computer Science A course with Java, which is our traditional AP Computer Science A course. And this course emphasizes on logical thinking and understanding of computers necessary to solve problems by writing programs. The course studies programming methodology, algorithm, and data structures. Students learn the subset of Java identified by the College Board entrance exam. And the course includes the syllabi, which is suggested by the AP Computer Science examination. The students do take Introduction to CS programming prior to enrolling this course, so they are a little bit more aware. And Python works very similar to Java, although Java is a little bit more class focused, so it's a step ahead of Python in terms of programming difficulty. We interested students always are encouraged to take advanced level courses, and we provide engagement, independent study engagement opportunities for them as well. The standards that we focus on are the national standards, which are the CSTA standards, but we also look at digital literacy computer science standards to sort of do more integration across curriculum as we approach computational thinking integration in different curriculum. Um, the unifying course ideas for our computer science courses are sort of analyzing the effects of developments in computing, which impact with impacts and connections. Equity is a key focus, so we design and implement creative solutions and artifacts, how to apply abstractions or models as we solve problems, how to analyze computational work and work of others so that we can provide meaningful feedback and work on prototypes. We collaborate with peers on computing activities so that, collaboration is a big piece of problem solving. And so, sort of understanding of what meaningful collaboration looks like and what creative feedback looks like as we are collaborating with peers. Our focus is always to design and implement solutions and sort of designing models that can help us test those solutions. Finally, there is a great emphasis on communicating using computational thought process, vocabulary, and a very database approach so that we are being very precise in our communication, especially about computing ideas. So our introduction to computer science course is a rigorous introductory high school course. It connects with the college prep A to G course objectives. It is inquiry based, equity based, and the projects are more focused on that. We have creative final projects that we engage in. Snap and Python programming are the two key languages which are used in introduction to programming courses. And we use multiple tools and multiple OS platforms to engage with the curriculum. The AP Computer Science A course, as you know, stands out in college admissions. There are over 2,600 colleges or more who take the AP's course. Uh, it is not advisable to skip the introductory classes as we talked about it. And we do build on college skills and student voice as we engage with making our AP Computer Science A course more interactive and accessible for our students so that the diversity of our student population engaging with this tool and creating solutions is broader and allows us to sort of engage more of our students in this in the curriculum and beyond, of course. Focus in WPS is always having more transdisciplinary, real world, problem based, project based learning opportunities. And here is an example of how we've been engaging students in our STEM week, computer science week, media literacy weeks. Please do visit our websites to see what's happening, the different resources that we talked about. And thank you so much for joining us today. I hope this was helpful. Thank you.